Good afternoon to everyone, and welcome to the virtual festival, AstroFest, South Africa's first digital astronomy festival, or as I more commonly like to call it, at least for 2020, AstroFest, the lockdown edition. Thank you all for joining us. My name is Pran Govender, representing the South African Astronomical Observatory, an entity of the National Research Foundation. Today has truly been a momentous celebration for the SAO. We celebrate 200 years as an observatory. Previously called the Cape Observatory, now known as the SAO, has allowed our institution to become the oldest permanent observatory in the Southern Hemisphere. Today, South Africa hosts the Southern African Large Telescope, more commonly called SALT. SALT is the single largest optical telescope in the Southern Hemisphere. These achievements allow us to celebrate these scientific advancements and take our place with contributions from the African continent globally. We present the virtual festival with SciFest Africa, known for implementing one of the largest science festivals in the country. SciFest Africa embarked on an ambitious 6-month digital festival ending in March 2021. On this note, I would like to welcome Mr. Clyde Foster. Clyde has a background in chemical engineering and has had a long and successful career working primarily in design, operations, and management in the chemical, petrochemical, mining, and energy sectors. Throughout Clyde's career, he has always retained his interest in astronomy. Clyde will today highlight the valuable contribution that amateur astronomers can make. He will take us through the detection of a new storm system on Jupiter that was actually discovered by Clyde, and believe it or not, is now called Clyde's Spot. Yes, Clyde actually has a spot on Jupiter. This was imaged 2 days later by the NASA Juno spacecraft. So on behalf of our teams, thank you, Clyde, and welcome to the virtual festival. Over to you, Clyde.
Thank you very much, Pran, for that introduction. I think if I can just get up and going with the screen share, then hopefully that can be seen. Yes, Pran, if I can add my congratulations to the South African Astronomical Observatory today for the 200th anniversary. It's wonderful that astronomy has had such a long journey in South Africa, and I think is very much active at this point in time. So it's an amazing achievement that we're celebrating today. I'd also like to thank the AstroFest and SAAO for the invitation to join you today and to share some of the experiences that I've had over the last couple of years in the specific field where I'm operating as an amateur astronomer. Now, my journey began many, many years ago, back in the 1960s. And it's one of the wonderful aspects of amateur astronomy is that you can very much as an individual decide to what extent you become involved in this as a hobby. It can be something very basic, like walking outside in the evening, and I hope this may prompt people to do it, but you can walk out in the evening tonight, look to the west, and you'll see a bright red star there, which is planet Mars. And in just doing that, you are taking part in amateur astronomy. But during my walk through life, I started way back in the 1960s. We were required to do a school project when I was in Scotland. And of course, that was the time of the Apollo missions, the moon landings, and I did a project on space travel at that stage. And that really initiated my interest in astronomy. It was shortly thereafter that my dad bought me my first telescope. And although the telescope is long gone, I was quite amazed the other day when I was cleaning up in my study to find the book that had come with the telescope. And this is it on screen here, just confirming that I got the telescope and the book in for Christmas 1969. So the family immigrated from Scotland in 1970, and I went through school down in Durban, achieved my chemical engineering degree. And throughout that time, I retained an interest in astronomy. Through my career, but obviously with the responsibility of a growing family and my career, I had relatively limited time to spend on astronomy. But when I did have the opportunity, I was out there, and I rewarded myself from time to time with larger and larger telescopes. And by the time the early 2000s came, I had an observatory in my back garden, but still very much of a subdued hobby, which escalated every now and then as I went forward. And then in 2013, 2014, I took a fairly significant step forward when I purchased the 14-inch Celestron telescope that you can see here. I also at that stage upgraded the observatory to have a roll-off roof system, which is motorized. And I was approaching the end of my career at that stage, and I certainly, having had this love for astronomy throughout my life, felt that there was a space for me to carry over into my retirement. So I made this investment, and as I look at that photograph now, I had no idea the journey that I was about to embark on in the following years. Now, there were a couple of aspects about the telescope and what I was going to be doing. It's a well-known telescope for planetary work. I was in an suburban or urban environment, so there was a lot of light pollution. So the planets, the brighter planets, were obviously a positive target. And that was pretty much the field that attracted me. So I started planetary imaging, and I can assure you the quality of the images were not particularly good. But I really was enthusiastic and fairly passionate about the path that I found myself on. And slowly but surely, I investigated all the techniques and the methodologies and the software that the leading planetary imagers like Damien Peach and Chris Go were utilizing. And slowly but surely, the quality of my images improved. And obviously with South African skies, the way that we have them, we have huge amounts of clear sky conditions throughout the year, certainly up here on the reef. And I started setting myself some personal objectives. The first was obviously to develop my skills in this specific field. And then I targeted specifically Mars, Jupiter, and Saturn as the planets that I would concentrate on. And what I found with the position of these planets over this last couple of years is it's almost become a full-time job for me. And as the quality of my images improved, I was requested to start uploading my images to some of the international databases, such as PVOL and ALPO Japan, where amateurs send their images in on a day-to-day basis. And of course, without knowing anything much more than that, I thought this was all very cool for an old toppy like me to be sending images into international databases. So as things developed, I slowly but surely came to the realization that I was in a field and on a journey, and maybe on a train journey, that I didn't know quite where it was going. But there were two key realizations that I picked up over the next few years. First, it was that there's a lot of people doing planetary imaging around the world. But I think Anthony Wesley in Australia has quoted a figure of about 50 who are an incredibly dedicated, hardworking, skilled, passionate team of planetary imagers across the world that I was being exposed to and came into contact with online. The second aspect was that these images that we were uploading, or I was uploading to the international databases, I came to realize that they were being utilized by the professional planetary community. Now, the professional planetary scientists have to fight and motivate and struggle to obtain time on the few large-scale professional resources that they have available to them, whereas we as amateurs are out there night after night, and with the techniques and the equipment and software that we have, putting out images which are easily being used for professional research in today's world. And on the back of that, one of the great highlights for me, and one of the first highlights, was me being invited to a Planetary Science Congress, EPSC 2017, in Riga, Latvia, where I was exposed to both professional and amateurs, fellow amateurs from around the world. And it was just an absolute eye-opener to me to have that experience and to realize the impact that we as amateur imagers are having in the field of professional planetary science. And just amazing experiences, amazing people that I was able to meet at these conferences. Now, one of the additional spin-offs from this professional amateur collaboration that I've been exposed to now was the support that amateurs are now involved in supporting the various spacecraft missions. Now, with me being obviously having Jupiter as one of my primary planets of interest, I was approached by a fellow amateur, I think it was Marc Delcroix in France, and requested to get involved with the mission. And just a little bit of a background to the mission. It was launched in August 2011 and arrived at Jupiter in July 2016. And it went into a highly elongated orbit. You can see it down at the lower right here, where it swings way out from Jupiter, and then every 53 days it sweeps in over the cloud tops of the planet. And when I'm talking about over the cloud tops, I'm talking to within a distance of 3,500 to 4,000 kilometers, which in real terms is very, very close to the planet. Now, the spacecraft mission has specific objectives and specific targets, but one of the instruments on board is the camera, which we call the Juno cam. And of course, you can imagine as the spacecraft sweeps in low over these cloud tops, to be so close to the planet, this camera is picking up absolutely incredible images of the cloud tops of Jupiter as it sweeps over. And in terms of the mission and the collaboration that takes place, I was able at the conferences that I've been invited to these last few years it's been a huge privilege to meet the members of the team, or some of the members of the NASA Juno mission team. Down at the lower right here, you've got Scott Bolton, the PI, who's basically the team leader or chief scientist on the mission. Candy here is responsible, has a number of responsibilities, but one of the key ones is the management of the camera imaging program on the spacecraft. And then Glenn Orton here, who is a specialist in near-infrared astronomy on the planets, but is heavily involved in coordinating amateur ground-based observations with the mission. This is actually him up here. I believe the photo was taken a few days before the mission launch. But Glenn in particular has really become an amazing colleague and in fact friend. And I think that's the amazing thing, is that online contacts in this field have gone from being contacts to colleagues and in fact to friends over these last few years. Another highlight for me was that in 2018, I was invited to to a workshop, a Juno workshop in London at the Royal Astronomical Society. And again, just another wonderful opportunity to meet leading imagers like Anthony Wesley from Australia, Jean-Luc and Marc from France, and Chris Go from the Philippines, who had a tremendous influence on my early development. And I presented a presentation at the conference. Now, the way that, just to explain a little bit about the collaboration, I've mentioned that the spacecraft zooms in over closely over the cloud tops of Jupiter every 53 days. And during that process, traveling from north to south, which the spacecraft does, it takes about 2 hours to cover that distance, which is approximately 140,000 kilometers. So it's moving very, very fast. And what happens is that approximately a week before what we call the flyby, which is the close approach, which officially is termed the Pj and is given a number. So the first close flyby was Pj-21, Pj-1. And for example, this map that I've shown here was for Pj-27. Now, a week before, we as amateurs take images of the planet that look similar to this. And there's a team, the JUPAS team in Europe, which takes these various images and then generates a global map of Jupiter. And they are able to superimpose the spacecraft track. Now, with the spacecraft being so close to the planet, it's got a very narrow range of vision where it can image. So particularly during over this region, the Equatorial region here, where it's so close to the planet, it has a very narrow field of view and then much broader over the North Pole and the South Pole. But these global maps are produced with the spacecraft track superimposed. And of course, the project team or the mission team is then able to identify any specific features very close to the track that the CANDI and the imaging team can then target while the spacecraft is flying over the surface of the planet. Now, due to the fact that it's so close and it's traveling so fast, we get these rather unusual shaped images coming back from the spacecraft. And when you look at them initially, they're quite difficult to interpret. And that's another role that we as amateurs play, where we've got the global view of Jupiter, and then the various images that have been taken from the spacecraft can be compared with the overall global view of the planet. So basically, one of the forms of collaboration is for the amateurs to provide context for the spacecraft images that are coming back. Just out of interest, there is a collaboration website with the Juno mission, which is called Mission Juno, and anyone is welcome to go on there. And in fact, what the mission team is upload the raw data that has come back from the spacecraft, and citizen scientists or amateurs are able to take that data and in fact process that data and those images themselves. And there's been some amazing work done by citizen scientists in that field as well. So on the 31st of May this year, we were all preparing for the Pj-27 Flyby, which was the 27th perigove of the Juno spacecraft. And it was coming up in a few days. And shortly after midnight, I was imaging Jupiter in support of that. Now, the typical process that I follow, we as amateurs image it through different filters, and this gives different data regarding what is happening within the chemicals and the clouds of Jupiter. So on the left here, upper left, you can see the RGB data that I collected. Now that is basically red, green, and blue, which we combine into a color image. And you can see the famous great red spot here. And you can see one of the long-lived cyclonic storm systems, this white one just to the lower right. And I normally go through a whole process of capturing RGB data to produce the color image. And then I'll move on to infrared, which produces this type of image. You can see the great red spot is much more subdued. And having gone through that process on the 31st of May, there was nothing particular obvious to me. And then I changed the filter to what we call the methane band. Now the methane band is a narrow band within the visible spectrum. And what this does is it highlights features that are high up in the Jovian atmosphere as bright. So for example, you can see in this image here, you can see the great red spot. And what this tells you is that the upper levels of the great red spot actually sit high, very high up above the higher levels of Jupiter's atmosphere. But what I noticed immediately when I saw this image on screen, again, you can see the light oval down here, which is again is long-lived. But I immediately detected this light spot here, which was very, very unusual. And one of the aspects that we look at as amateurs is potential impacts, asteroid impacts on Jupiter. And I initially thought it might be in some form of impact, but they normally last only a few seconds, and then they disappear. This continued, so I realized it wasn't an impact. And in discussion during the course of the following 24 hours, it became pretty obvious that it was a storm system that had suddenly developed. So now these storm systems, or what we call outbreaks, are common on Jupiter. So why the interest and specific excitement related to this one? The point being is that this specific region of Jupiter, the South Tropical Zone, very rarely has outbreaks. So it was a rare occurrence in terms of the region where the storm was observed. And then secondly, and I have to thank Andy Casely here, a fellow imager and friend from Australia, he actually captured an image 10 hours prior to mine, and there was actually nothing there. So an exciting factor was that this storm was literally had just occurred or was still occurring while I had caught it. But far and above all the various other aspects, the most exciting by far was that we all realized that the NASA Juno spacecraft was going to be flying over this region or very close to it within the next few days. So with these type of storm systems, to be able to get a detailed image is something very, very special from a spacecraft. So I got hold of Candy and we were able to have communication, and she was able to confirm that they were going to be able to catch this storm during the flyby. So we all waited with anticipation. And true to form, well, Juno just does not disappoint. On every one of its flybys, the spacecraft has sent back stunningly amazing images of Jupiter in all its glory, covering amazing cloud formations and dynamics of the atmosphere. And this image on the right here, you can see the great red spot. This was as the spacecraft had come over from the north down over the Equatorial Zone, and it swept down in this region here, and it was going out over the South Polar Cap or South Polar region. So you can see the great red spot, and you can see the oval that we had picked up in my amateur images, and there we could see the storm. And in the meantime, both within the planetary or the professional and amateur planetary communities, the storm had been given the name Clyde spot. It was first used by Paul Maxon in the States, and the community just picked up on the name, and it stuck. And this is just one of the beautiful images of Clyde spot that the spacecraft was able to pick up, and you can see some of the cyclonic structure of the storm. And this is obviously being investigated in incredible detail by the professional planetary science community. So the days went past. The amateur community, as we do the various planetary images, if someone detects something interesting, the team that I mentioned about, the 50 dedicated, committed planetary images around the world, they jump in, and they're out there night after night supporting that that initial detection. And we had that with the specific instance where we were able to track the development of the Clyde spot storm. And I was keeping in contact with the Juno team, and I was aware that a press release would eventually come out related to the flyby. And I was hoping, of course, that there would be some mention of Clyde spot in the press release. Little did I expect eventually that when NASA put out the press release, that they would headline the whole Clyde spot story. I was just totally blown away. They went out on Twitter, they went out on Instagram, Facebook, and YouTube, and they went just full on with the story of Clyde spot. Scott Bolton, I had some, if you remember the PI on the mission, I had some communication with him, and he said he was just loving sharing the story of Clyde spot when he was having meetings or presentations. It was just an absolute classic case of amateurs collaborating with the mission team and having just incredible success. So, and of course, with NASA having gone out big in the media, it extended way beyond the astronomical media and went into the general media domain. You can go on Google searches. There's enough references there, and I was very privileged to be included in a carte blanche program on the 16th of August this year, where I was interviewed, firstly regarding the latest Mars missions, but they included a very nice insert related to Clyde spot and the work that had been done. So a few points to take away from this. If I can just highlight to you that amateur astronomy can be an incredibly exciting hobby. I find myself on a journey of these last couple of years that I could never, ever have dreamed about. Amateurs can make a serious contribution in the field of astronomy, and they are doing that, not only in the field where I'm operating within planetary science and interacting with the NASA Juno mission. There's a number of other areas where amateurs are making serious contribution, and I'm just incredibly thankful for these last number of years where, as I say, I've had some of the most exciting, satisfying, personally rewarding years of my life, and that's primarily due to the community that I've been privileged to become involved with. As I mentioned earlier, you don't have to get involved to the extent that I am. It's obviously expensive to have the equipment that I have. But to have youngsters the way that I was back in the 1960s, where I had a small telescope and I was out there looking at the moon through this little telescope and looking at double stars and galaxies and nebula, you can do that. And what I would encourage you is that if in some way I've prompted your interest in astronomy, get hold of one of look up your nearest ASA branch, the Astronomical Society of Southern Africa. If you're in a region where we don't have a branch, look for your closest astronomical society. There are others as well. And I would encourage you to explore your interest. You'll always be welcome at the meetings. There will always be people that we will be willing to guide you and assist you along the road in your exploration of astronomy. Now, I would just like to close off with a few special thanks. Firstly, to NASA and my friends and colleagues in the Juno team. It's been an amazing relationship that we've developed over these last number of years, and of course, the whole story of Clyde Spot was primarily due to Juno and the press releases that NASA put out. And of course, to my friends and colleagues in the Pro-Am planetary community, those people like myself that are out there night after night, waiting to see whether there's anything special happening on those planets and to share it with the world. And finally, I would like to thank you for listening. I hope that I've instilled a little bit of interest in astronomy in your minds. Thank you very much. If I can pass over back to Pran.
Fantastic. Thank you, Clyde. And I think from all of us, thank you very much for the contributions that you're making. I noted one of the dates was 1969 on the postcard, so I'm definitely not going to ask you how young you are, but definitely, I mean, these contributions that you are making have actually contributed to South Africa's contribution, in a sense, to what we can offer to everyone out there. So a few questions have come through, and I'd like at this point to start taking questions from our attendees, both here in our Zoom and also on Facebook. Please use the chat function to ask us some questions. So the first question coming up is from Steve Sherman. Is the integrity of photos that are submitted ever questioned? With software edits, distortion from lenses, etc., how does one check the authenticity of the quality of the images that are captured?
Bran, sorry, I didn't get everything there. Is he referring to the amateur images or the spacecraft images?
So I think to the amateur images.
Okay. In terms of the quality of the images, Bran, if you go onto any of the databases, you'll see, as I mentioned, there's hundreds of people that are taking images and in fact loading up to the databases. But there's a huge range of quality. As I say, there's a relatively small number of people, and Anthony Wesley has quoted a figure of about 50 that really are putting out extremely high quality images of the planets. But I've been told on a number of occasions by professionals, sometimes we have atmospheric conditions that are very poor, and yet even relatively low quality or low resolution images can still add value if there is some dynamic development taking place on the planet. So there's such a wide range from incredibly high resolution, high top quality images by a few of the best planetary imagers in the world, ranging all the way down. And of course, the professional planetary scientists assess the images on a day-to-day basis as to whether they can use them or not use them. There's obviously a lot of lower quality images that people are putting out just because they are excited about taking a photograph of the planet. They're not trying to necessarily add scientific value in any way whatsoever. They get an absolute kick out of just seeing that globe, whether you can see any detail on it or not. They can say that they've taken a picture of Jupiter or Saturn or Mars, and that's their picture. And no one can take that away from them. And certainly no one is going to criticize them for that. But But obviously, when the better quality images, they are measured. Obviously, detailed features on the planet are, the movement of those are measured in detail. And you obviously need a certain quality of image to be able to do that.
Perfect. Thank you for that, Clyde. Just a reminder for everyone to use the question and answer feature on our Zoom chat to further ask any questions if you have them. The second question is from Camille Anirod, and he says, "Hi, Clyde. Thank you for sharing your story and work with us. What equipment do you use to be able to track and follow the path of Jupiter as it moves across the sky from your perspective?"
Okay. Maybe I can just explain a little bit about my equipment. The image that I showed you early on was the 14-inch Celestron, and that's one of the better amateur telescopes. It's a Schmidt-Cassegrain type telescope, so it's got a reflecting optical system. And it's got a fairly long focal length, which is very suitable for planetary imaging. Now, as the question asked, they're obviously fully aware that the Earth is rotating. And I wonder if it's not worthwhile me just resharing the screen, and I can maybe just go back and show the equipment again quickly. Okay, so yeah, obviously you've got the optical part of the telescope, and then you've got the system here, which is what we call a German Equatorial mount. And this is all computerized. This is the system that I have in the observatory. This is just the system or the processing that I do in my study in the house. But this is all computerized, and it's all finely aligned for the system to track the movement of both the stars and the planets across the sky. We're dealing with a very small field of view when we're talking planetary imaging. So you have to have very accurate tracking. But there's also software that if there's slight irregularities, then the software will also adjust for that. I haven't shown the system. The camera system is at the back here. And the technique that we use as amateur planetary images is a system that we call lucky imaging. And over the last number of years, this is probably a field where we've seen the greatest steps forward and the greatest development in technologies in the cameras. And what we do and what's been developed is very high quality, effectively webcams and video cameras. And the reason that we use this technique is that if you can visualize that from ground level up to the upper layers of the atmosphere, and I'm going up like 30, 40, 50 kilometers, there's various layers of the atmosphere where we can have temperature changes, we can have density changes, we can have winds, and it's almost like an ocean of atmosphere that we're observing through. And that can cause absolute devastation for the sharpness of the image. You get some nights where it's incredibly stable, and those are the nights when guys like myself will be out there from 6 o'clock in the evening until 6 o'clock in the morning, just capturing gigabytes of data. But there's other nights where you've got this turbulence that takes place in the atmosphere. And by taking high-speed video of the planets, we end up with thousands and thousands of these images captured over like a minute. And we've got incredible software that's been developed, which will analyze each of those thousands of images. And it'll pick out the sharpest ones and allow us to use those ones to then combine and align and stack them into the best possible sharp image that we can get. So there's all these different techniques that we use, but lucky imaging is an incredible technique that is used by all the leading planetary imagers. High-speed video, where we capture thousands of frames over a period of about a minute, and then we've got the software to analyze and then combine them into the sharpest possible image. I think that covers most of the main equipment that I utilize.
Perfect. Thanks, Clyde. The next question we have is from Lafras Smith. Hi, Lafras. He says, is Clyde spot still visible, and did scientists learn anything new about Jupiter after the spot appeared?
Right, let me just go back there. The answer is yes. Clyde spot is still visible. I keep a very close watch on it, night after night when I get the opportunity. It's been quite incredible. What the storm is at when it was first detected and captured by Juno is a dynamic upward plume of gas that is erupting out of the upper layers of Jupiter's atmosphere. I've in the carte blanche interview, I referred to it or visualized it almost like a nuclear mushroom cloud. I think most people have seen what that would look like, and to some extent this is how I visualize it, and diagrams that I've seen in professional papers tend to support that view a little bit. So we had this plume of material or gas that got blown out above the upper layers of the atmosphere. But within about, I think it was within about a month, I was invited by Glenn Orton of the NASA Juno team to sit in on an observing session on Mauna Kea, the NASA IRTF observatory on Mauna Kea, Hawaii. And I was very privileged to sit in on that. And that's the infrared telescope that they use. And it was amazing. We saw Clyde spot through the IRTF, and it actually showed it a very dark spot in the deep infrared range of the spectrum. So what it had shown was that within a month, it had gone from an upward plume. The dark spot in deep infrared indicates that it was actually a hole now. So it was a clearing in the upper atmosphere. So it had gone from an upward plume and almost formed if you want, a little bit of a vacuum, and actually then formed a hole. And I've sat in on a number of observing sessions, some of them fairly recent, and it's retained that structure. And in the RGB, or the visual spectrum or color, it's also showing as relatively dark now. And so the term Clyde spot is being historically referred to now as the initial outburst of the storm, and that terminology will thankfully be kept for posterity. Now, the dark feature that is formed more recently has got the rather, if I can say, bland name of DS7, which means dark spot 7, because there's been a number of dark spots that have been in that particular zone of Jupiter. So the answer is yes, it is still visible. I still track it, although Jupiter is getting further away for us now, not that easy to image in detail now, but we're certainly still tracking it. And as I mentioned in my presentation, there is a presentation being given at the Division of Planetary Sciences in the United States. I think it's next week, where the team from Bilbao University in Spain. This is the group down here, Ricardo and Agustin from Bilbao University. They are presenting a very detailed paper on Clyde Spot at that conference next week.
Thanks, Clyde. The next question we have coming up from Kaylin Esterhazen. What was your favorite discovery you made or that you were part of?
Thanks for the question. I think it has to be Clyde Spot. But there's been many along the road. I think obviously when I started imaging back in 2014, the quality of my images was not particularly good, but Mars was very well placed when I started, and I got pretty, went over the top in terms of my Mars imaging, and I was putting out all these pretty low quality images. But with Mars being in the southern hemisphere, the European observers were not able to image. So I became one of the observers that was able to follow Mars through the second half of the year in relatively low quality, but I was doing it. And I was submitting my images to the British Astronomical Association. Richard McKim heads up the Mars section there. And a couple of months after I started and started sending him images, I saw something strange from one night to the next. I saw a bit of a light spot on Mars, and I sent him the images. And I was a bit stunned when about an hour later, I got a global alert from the BAA saying that there was a dust storm that had been detected by Clyde Foster in South Africa. And they were requesting observations from around the world to try and follow this dust storm. So that was obviously being one of my first experiences of making an impact. That was obviously a very special experience for me as well. But there's been a number of other special experiences, Bran, not only within imaging. I can maybe just share one very special one related to the EPSC conference in Riga. Myself and Glenn Orton from NASA and John Rogers from the BAA Jupiter section, we were sitting in the pub having a bit of a drink and chatting, and then suddenly this gentleman came to join us, and of course Glenn and John knew who it was. I'd never met him before, and we got introduced, and I said, "Hi, I'm Clyde," and this chap turned to me and he gave me a very warm handshake, and he said, "Wow, Clyde from South Africa." and I like stepped back a little bit, and I said, "Yeah." I didn't know who this guy was. And he said, "Sure, what a pleasure to meet you. I just want to say how, what a contribution you're making, and it's amazing, and we're incredibly impressed with the work that you're putting out from South Africa." And of course, I didn't want to be rude, so we carried on chatting, but after a while, I excused myself. And then, of course, at that stage, I'd known his name, Dr. Lee Fletcher. And I went and quickly Googled who I'd been introduced to. And Lee is one of the leading specialists in planetary atmospheres of the outer gas giants. Really one of the top planetary scientists in the world. And it was just an absolute eye-opener for me. It was a moment in time that here was me, having been in my little back garden observatory, taking pictures of the planets, And now I'm suddenly in a place like Riga, Latvia, and I've got a guy like this acknowledging the work that I'm doing in my little back garden. But there's been so many occasions where I've sat in on professional presentations and Lee did it again, I think in Geneva. I was sitting in on one of his presentations and he was talking about a feature on Jupiter, and he said, oh, by the way, I see Clyde Foster at the back of the auditorium there, and he's taken a lot of these images. And the acknowledgement that we as amateurs get from the professional community is just beyond belief. But at the same time, the exciting thing is that we are getting affirmation that we're making a contribution. And that is without doubt one of the highlights for me over these last years.
I definitely agree, Clyde. And you're just reminding me that the next time we have the opportunity to meet in person, I would have to get your autograph. I think one day it's going to be something quite substantial if I ever want to sell it, actually. The next question, actually, one of my favorites is from Loic. I hope I'm saying the name correctly, age 6, and would like to know, if you were asking Father Christmas for a telescope this year, which telescope would be the best?
Yeah, I know the answer to that one. I can answer that. Yeah, I'm continuously assessing the situation that I'm in, and you just can never. Yeah, you're always wanting a bigger and better telescope. Specifically for planetary imaging, I know there's some planetary imagers that also get involved with other areas of astronomy, wide field, deep sky imaging, and I must admit, for the time being, this is my journey and the journey that I want to stay on. And if I was going to upgrade, I would probably be looking at a classical Cassegrain type telescope, and ideally in the range of 18 to 20 inch. But I'm afraid to say that if commercial telescopes of that cost you probably well over R500,000 for those telescopes, and that's a little bit outside my budget, I'm afraid. But it's interesting. I've had discussions on these matters with other planetary imagers, and Damien Peach, obviously one of the world's leading imagers as well, and he's pretty much confirmed that the C14 14-inch that I've got is very much one of the better scopes. And you know, one of the aspects, and I mentioned it a little bit earlier with the ocean of atmosphere above us, is that dependent on where you are can be the limiting factor. So you can get a bigger and a better telescope, but that does not necessarily mean that you're going to get better quality images, because the limiting factor is the quality of the atmosphere and the turbulence in the atmosphere in your specific location. And that's an area that I'm looking at in a lot of detail. It's a project that I've got on my list, is to assess the various atmospheric conditions around the Southern African region, in terms of whether it's worth my while relocating, maybe to try and capture better quality conditions. Where I am now, I don't think it would be worthwhile expending additional cost to upgrade the telescope, to be honest. The limiting factor where I am is the atmospherics. And if I relocate, I would be very much looking forward to a better telescope, but within a budget. And
Thanks, Clyde.
And sponsor me, of course.
Thanks, Clyde. I'll get back to you on the sponsorship. So what would you recommend then for Loic? If he had the opportunity of asking Father Christmas, for a telescope, what should he get?
Look, it all comes down to what you can afford at the end of the day, Brian. I probably overstepped a little bit with my investment in the C14, but it's turned out to be one of the best decisions that I've ever made, and I've got zero regrets. I think what you get is people who and I've had it so many times where people get excited about seeing my images, and they go out and they want to go and buy an expensive telescope in the hope that they're going to get the same type of images. It's been a long journey that I've been on, and all those that are putting out good quality images, it's not something that you happens in the space of a week or two. There's a lot of people now that are prepared to give support. But in terms of buying a telescope for yourself, the first question I always ask is, what are you wanting to do? Not everyone wants to go and image the planets or take high resolution images of the planets. Maybe a low resolution or just seeing the rings of Saturn is going to be satisfactory within the budget that they have. So, you know, typically I would recommend for someone who's starting off, you know, maybe a 6-inch telescope, that type of range where you're not spending a huge amount of money, and it allows you to get into astronomy and allows you a wide range of objects that you can see. But just to reiterate what I said earlier, in terms of that, if this presentation has perked your interest in astronomy, get through to your nearest astronomical society, whether it's your local ASA group, as we're scattered around the country, and if there isn't one close, then get hold of one of the other ones, if there's one closer to you. And I can assure you the astronomical community is a very cooperative, supportive group of people. I can vouch for that, extending all the way up to the people that I interact with. And take the opportunity. People will invite you to go and look through their telescopes. Most of the ASA groups have a monthly observing session where there's a number of telescopes. Take your time before you spend money even. Go and have a look through other people's telescopes. There'll always be people wanting to show you what you can see through their telescopes.
Thanks, Clyde. So I'm getting a lot of feedback coming to say, Lloyd, thank you very much. We definitely want to try and find Father Christmas to help you with your telescope. So Lloyd, please try and get in touch with us and leave us your details, and we definitely will get back in touch with you. I'm going to try and speak to Father Christmas myself and see what I can do to try and at least assist you on this journey. The next one, Clyde, is from Glenn Orton. He says, Clyde, thank you for all your hard work and your encouragement for more amateur observers and generating interest in the Juno mission. We hope it will encourage more to provide the context and evolution of atmospheric features to help us on Juno, particularly if the mission is extended. Fingers crossed. Thanks, Glenn. Thanks for that one. The next one is from Padma Fisher, Yamanandra Fisher. Clyde, a great talk. You illustrated the role and importance of amateur astronomers in scientific research. Thank you for the related science and outreach too. This is a great topic for citizen science. And I'm just going to check if we have any more questions. Clyde is being too modest here again from Padma Fisher. I first met him in 2014 when he was observing comet siding spring and its flyby of Mars. So definitely, Clyde, we're starting to see you've been in this business for a very, very long time. I
can maybe just just mention there that obviously Glenn is on the NASA Juno team, and
yes.
and Padma, I think it's Space Science Institute that Padma is with, but Padma, together with a few others, has been an absolute key role player in the development of what we call the PACA groups, which is the professional amateur collaboration in astronomy groups. And she set up all these different groups for the different planets. So there's one for Jupiter, Mars, Saturn, Uranus, Neptune, all of them. But she's also involved with Packer groups on the comets. She's just done an amazing amount of work building up professional amateur collaboration in this planetary field.
Great, thanks for that. And then the last one from Camille Anirudh, before we sign off, he says, would it not be a dream to relocate to Sutherland? I'd like to hear Clyde's response on this.
I've obviously been at Sutherland, a wonderful experience. I had a personal tour around SALT and a few of the other telescopes. I've been in contact with a few of the professionals down at SAAO, and also there's the Falks telescope system, which is operational down at Sutherland, and I've done some preliminary explorations in terms of whether I can do remote observing from Sutherland, and that's definitely a possibility. When I was down there, one of the aspects was that I did want to assess whether there would be benefit in me relocating to Sutherland. So it's certainly a question that I've seriously considered, and for various reasons. An interesting one was that when I spoke to the people at SAAO, it does appear that there's been a little bit of a degradation in atmospheric conditions at Sutherland over the last 20 or 30 years now. Whether that's I don't know the details of that, but it's an interesting one. But as I mentioned earlier, I've got quite a serious project that I've got lined up to assess the atmospheric conditions across the whole of the Southern African region. From a planetary perspective, there's certainly benefit in being further north. Two key reasons. One is that as the planets move north again, then at least they'll have a little bit of better elevation for imaging. Obviously, if you're imaging very low down on the horizon, the atmospheric conditions will be very, very poor. And the second one is that we've got the jet stream, which is a high altitude, high velocity wind that can have very negative effects on imaging. And the further south you are in South Africa, the more impact the jet stream appears to have. So going further north is probably a better option for me in terms of my specific interests.
Great. I think, yeah, with regards to specificity, it depends on what kind of science you're doing. But I would strongly encourage anyone who needs to see the actual beauty of the night sky to take a trip to Sutherland. It's definitely worth it. Sutherland boasts some of the darkest night skies, and it's one of the most beautiful sights that you'll ever see as we move away from light pollution. At this point, I want to thank you, Clyde, very, very much. What an interesting journey you've taken us on. And we're definitely looking to and monitoring you actually to make sure that we're not sure when we're going to have Clyde's name appear on other planets. So it's something that we're really looking forward to. Thank you for joining us and being a part of our team. On behalf of the...
that, Pran, very, very much so, and to everyone that joined us as well.
Thanks, Clyde. Perfect. On behalf of the SAO and the SciFest Africa teams, thank you very much for joining us, and follow and like us on Facebook and Twitter. Again, SciFest Africa has a really ambitious 6-month program. Please like and follow them for more information on what's to come. Thank you very much. Cheers.